So today we're going to look at factors, and when we look at factors, we also generally talk about primes and composites and what those are. So factors are numbers that go into another number evenly. So for example, if we're talking about 24, we could list its factors. But what a lot of people will do is they will try to do this. They'll try to say, oh, well, factors of 24 are, let's see, I know 1 and 2 and 4 and 8, and they'll just try listing it that way. But we really need to do a more organized way of doing this. So let's talk about how we can do that. One way to do that is to use something called the horseshoe method. And what that means is, starting with the smallest factor of 24 that you can think of, list factors of 24. So we do that by thinking of multiplication problems that give us 24. So of course we can say, does 1 go into 24? Yes. 1 times 24. Does 2 go into 24? Yes. 2 times 12. Does 3 go into 24? Yes. 3 times 8. Does 4 go into 24? Yes. 4 times 6. Does 5 go into 24? No, it doesn't. Does 6 go into 24? Yes, it does, but 6 is already right here on our list. So that means that we're done because we now have gotten to numbers that are on the right-hand side of our multiplication list. So once we get that far, then we can list off all the factors. And I call this horseshoe method because if you look at it, the list of factors, if you write them from least to greatest, makes a horseshoe shape. So we could say the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And that's a really organized way to do it and make sure we don't accidentally leave out some factors. Let's look at another example. So try finding factors of 80 on your own. Pause while you do it and then check. So factors of 80, I would think of 1 times 80, then does 2 go into 80? Yes. 2 times 40. And if I wasn't sure how many times it went in, I could always divide 2 into 80 and figure it out that way. Does 3 go into 40? No, it doesn't. Let me tell you a trick for knowing whether 3 goes into a number. Add together the digits of the number you're trying to figure out. 8 plus 0 is 8. Does 3 go into that? No, so it won't go into 80 either. So 3 doesn't go into 80. 4 does, though. 4 times 20. So does 5. 5 times, again, if you're not sure, do the division. Figure it out. 5 goes in 16 times. So 5 times 16 is 80. Then does 6 go into 80? No. How about 7? No. 8 does. 8 times 10. 9 does not. 10 is already on the list, so I know I'm done. The factors of 80 are 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. That's one method for listing factors. Another method for listing factors that's kind of similar is the rainbow method. It's similar in how you think about it. It's just different in how you write it. You don't write out all the multiplications. You just write your list. So if I want to think about factors of 32, I would think about the first factor pair or first multiplication I can use, and that's 1 times 32. Notice how I'm writing my list. I'm starting from the outside, the left, and the right, and working my way in. So the lowest factor on the left and highest factor on the right. So lowest on the left, highest on the right. So 1 times 32. Does 2 go into 32? Yes. 2 times 16. Again, notice how I'm working my way in. My next lowest and then my next to the highest. 3 does not go into 32. 4 does. 4 times 8. 5 does not. 6 does not. 7 does not. And then I'm on to 8. And 8's already on the list. The reason you call this the rainbow method is because if I used this method, I would be able to connect the factor pairs, and they're going to make a rainbow. So 1 and 32, 2 and 16, 4 and 8. And I could show this with one of the others that we just did. For example, we did factors of 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8. 4 and 6. And if I use the rainbow method to connect them, 1 times 24, 2 times 12, 3 times 8, 4 times 6. And all of my numbers are going to match up. The only time they don't is when I have a perfect square, which we'll talk about another day. And that's when I have just a number, for example, like 25, where 5 times 5 is 25. 5 would be in the middle by itself. So looking at some more examples, or looking at some classifications rather, we classify numbers greater than, or we classify whole numbers rather, positive whole numbers, as either prime or composite. Prime numbers have exactly 2 factors. Those factors are 1 in itself. So for example, numbers like 5, its only factors are 1 and 5. Or 17, its only factors are 1 and 17. Those are prime numbers. Composite numbers are numbers which have more than 2 factors. So all the others we've looked at right now, 32, 80, 24, those are all composite numbers. And when we classify 1 and 0, we cannot classify them as either prime or composite. They are neither. So when we're talking prime and composite, we're talking whole numbers from 2 up. So I'm going to give you some examples. Let's try 16 and 13. Try listing the factors of those and then deciding whether you think they're prime or composite. Once you've done that, check your work. So pause while you're working, and then once you're done, check your work. Okay, for 16, you should have gotten 1 times 16, 2 times 8, and 4 times 4. So factors of 16 are 1, 2, 4, 8, and 16. Notice if I used a rainbow method to check that, I would say 1 times 16, 2 times 8, and 4, again, is in the middle by itself. And the reason it's in the middle is because it's a perfect square. Anytime you can multiply a number by itself, and that's a factor pair for a number, then the number that those are factors of is a perfect square. 16 is a perfect square. So those are our factors of 16. It has more than 2 factors, therefore it is a composite number. 13. The factors of 13 are 1 and 13, and that's it. So 13 is a prime number. Try a couple more. Remember to pause and then check your work. All right, so 51. Of course, we have 1 times 51. But 3 also goes into 51. That's a factor that people often leave out. And I know 3 is a factor because 5 plus 1 is 6, and that means that 3 is going to go into 51. If I wasn't sure how many times, I could always divide it out in work and figure it out that way. But it's going to be 3 times 17. So factors of 51 are 1, 3, 17, and 51, and that makes 51 a composite number. And our last number that we're going to try is 48. Hopefully you've gotten all the factors. There should be 10 of them if you've done it correctly. So if you don't have 10, go back and try again and then check again. All right, so you should have gotten 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. That means that our factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48, meaning this is very much a composite number. Now, just a quick little history lesson, something kind of interesting. There is a guy named Aristophanes, and he lived in Egypt. He was Greek, lived in Egypt back in, about 2,000 years ago, the 200s BC or BCE. And he came up with a method for how you can identify prime numbers. Now, we could go all the way from 1 up to 1,000,000 if we wanted to using this method, but we're just going to do 1 through 100 because it's just easier. We're just going to go just that far so you can get the idea. The first thing he said is, I know that 1 is neither prime nor composite. So he said 1 is neither. And then he said, I know 2 is a prime number because the only things that go into it are 1 and 2. Therefore, any multiple of 2 has to be composite because not only For example, for 4, not only are 1 and 4 factors, but if it's a multiple of 2, then 2 is also a factor. If 2 is a factor of 6, then 6 has to be composite because 1 and 6 would also be factors of it, of course. So any even number is going to be a composite number, any even number except 2. So he went through and he said, I'm going to get rid of all these even numbers. All of those numbers are composite. So notice how very quickly he's starting to whittle down which numbers are which. Once he got rid of all the even numbers except for 2, because that one was a prime number, he said, well, my next number that's not classified is 3, so it must be a prime number. Then any multiple of 3 has to be composite. So 3 of course is prime, but then 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. We're really getting somewhere here now. So the next thing he said is, I know that 4 has already been classified as composite. 5 is not classified. It must be prime. Any multiple then of 5 has to be a composite number. Well, all the even multiples of 5 are already gone. So we've got now 25, 35, 55, 65, 85, and 95 left to cross out. So he looked again and he said, okay, the next number that's not classified is 7. Therefore, it must be a prime number. So 7 is prime. All multiples of 7 must be, all other multiples of 7 must be composite. So 14, 21, 28, 35, 42, 49, 54, 56, 63, 70, 77, 84, 91, and 98. Then he went back and he said the next prime number is 11. 11, all of its multiples are already out, and in fact, everything that's left right now is a prime number up to 100. So our prime numbers from 1 to 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. And that was his method of classifying numbers as prime or composite. Now, if you're looking at this, you probably want to know circled means prime and X'd out means composite. And you could use this method, like I say, to go as high as you wanted to, but for practical purposes, probably this is about as high as you would want to go.